Welcome back. In the last class, we have seen how to determine the standard gate capacitance for different technologies. Just recall here, if you observe that the standard gate capacitance may be evaluated for any MOS process. Okay, in the last class, we have seen about 5 micrometer technology. How we determine the 5 micrometer technology, you can observe that. First of all, we have determined area per standard square. That means whatever the technology they have given. Okay, then you should assume that the length and width are same. Why? Because it is a standard in a sense a square. Is it clear, all of you? Okay, now you can observe that how to find out area per standard square. Length into width, that means length and width both are same. 5 micrometer into 5 micrometer will produce 25 micrometer square. Is it okay? Then after that you have to find out the capacitance value from the table of typical values of capacitance. Now you can observe that what is the value of capacitance for 5 micrometer technology? Absolutely, that is what 4 into 10 to the power of minus 4 picofarad per micrometer square. Is it clear? Now after that you have to find out the standard value of gate capacitance in this manner, area per standard square into the capacitance value, then you can get this value. Is it clear? Similarly, for different technologies, let us consider 2 micrometer technology and 1.2 micrometer technology. Okay, now area per standard square is, since it is a 2 micrometer into 2 micrometer, then the capacitance value from the table is 8 into 10 to the power of minus 4 picofarad per micrometer square. After multiplying these two, you may get the value of 0.0032 picofarad. Is it clear? Similarly, for 1.2 micrometer, you can observe that the value is given as 1.2 micrometer into 1.2 micrometer. Then you can observe that, and the capacitance value of orbit 1.2 micrometer technology is also the same value. You can observe that. Okay, but it is double. Okay, that means for 5 micrometer is 4, for 2 micrometer it is 8, for 1.2 micrometer it is 16. 4 2 is 8, 8 2 is 16. That is a very simple way to remember. Then you have to multiply these two values, then area per standard square into capacitance value, then you may get this. Okay, this is we have determined. In this way we have determined the standard unit of gate capacitance. Once again I am telling that here the standard, in a sense it is a square where the length and the width are same. Is it okay? Now you can observe some area capacitance calculation. This is a very important thing you have to talk about. Okay, now we can see some area capacitance calculation. First of all, we will talk about the formula. Later we will talk about with examples. Is it clear? Now you can see how to determine some area capacitance for different layers. Let us consider if you are having a metal, if you are having a polysilicon, if you are having a diffusion, how to determine the area capacitance for these three layers or the combination of these three layers. We can observe the only formula we are having is relative area into relative C value. You should be very clear with this. This is a relative area, this is a relative C value. Here relative C value, in a sense, in our table you have the values in the parenthesis, you can call it as a typical C values. Okay, is it clear? That is a relative C values. That is a very important thing you have to determine. Is it clear, all of you? In your table, whatever the values you are having in the parenthesis, that becomes the relative C value. Is it okay? In the typical values of, if in the typical capacitance values table, you can observe this one which is present in the parenthesis is known as relative C value, and you have to find out the relative area. Is it clear? Now we can see some example. Okay, how to determine the capacitance of some layers. What is the formula? Once again I am telling that. Okay, relative area into relative C value. Is it clear? Now let us consider in the figure, you can observe that I have considered one area. Okay, let it be either metal, let it be either polysilicon, let it be either diffusion. First of all I am talking about, let us consider it is a metal. Okay, now what is the length given here for this area? Absolutely 20 lambda is given. What is the width they have given? 2 lambda they have given. First of all you are going to, 3 lambda. First of all you are going to find out the area. What is that? Length into width. Okay, length into width. What is the length? 20 lambda into 3 lambda. That is the general area, but you have to find out relative area. That means with respect to the standard square. We know that when the layer becomes standard, when length and width are same. That means we know when it will be a transistor for standard one, when poly crosses diffusion or when diffusion crosses poly. We know that very well, 2 lambda by 2 lambda. Therefore, the relative area calculation should be done in this manner. Is it clear? Now you can observe here. You can observe very clearly here. Okay, length into width. This is length and this is width. This is a standard one. Is it clear? Now you can observe very carefully. The lambda gets cancelled here. Okay, I will take some more fine. Okay, lambda gets cancelled here. Lambda gets cancelled. Then what are the remaining things you can observe? Absolutely. Okay, 2 2s are 4, 4 5s are 20, 5 3s are 15. This is relative area. Okay, what is the relative area for this given? Okay, layer, whether it may be metal or diffusion or whatever it may be polysilicon. What is the relative area? 15. Now very importantly, if you assume it is a metal, then you have to find out the relative C value of it, then you should multiply with 15. Okay, 15 won't be changed. Only if you assume it is a metal, then the relative C value will change. If it is a polysilicon, relative C value will change. If it is a diffusion, relative C value will change. Is it clear? According to table, you can observe what are the relative C values. For that, you can observe very clearly here. If it is a metal, what is the relative C value you are having according to the table? Absolutely. What is that value? You can observe very clearly. The relative C value is what? 0.075 standard gate capacitance. Then simply what should you have to do? You should multiply with 15. That is the relative area. Is it clear? Now, if you assume that it is not a metal, if you assume that it is a polysilicon, you can observe that if it is a polysilicon or else if it is a diffusion, you can observe very carefully. Just the relative C value is going to be multiplied with the relative, the relative area is going to be multiplied with the relative C value. What is the relative C value of polysilicon? 0.1 standard gate capacitance. And what is the relative C value of diffusion? Whether it n-type diffusion, 0.25 standard gate capacitance. Is it clear? Simply in this manner you have to find out if they given any layer and they said to determine the capacitance of that layer. Then first of all you have to find out the relative area. After that you have to find out the relative C value from the table. Okay, the table won't be given in your examination point of view. You have to remember that one. After that you should multiply these two. Is it clear? Then you may have the capacitance of that layer. Is it clear? Okay, in this manner you have to find out it. Okay, it is very easy, I think so. If some combination of different layers they have given, then how to determine it, we will see that in the next class. If you are having any queries in that, please try to comment. Okay, if you are having any queries. Thank you very much. Have a nice day.